In the previous video, we have seen how Mendeleev worked on arranging the various elements to give rise to a proper periodic table. In this video, let us discuss the merits of Mendeleev's table of elements in detail. One remarkable notation of the table was that it had empty spaces. That is, many positions were kept blank for elements that were not discovered at that time. Mendeleev was quite confident about his work and knowledge. As a result, he strongly put forward a few properties as a part of his prediction. He suggested a few characteristics of the missing elements. Now you may wonder as to why this is an achievement. The answer to this is because when the missing elements were discovered, they showed almost the same properties as predicted by him. Amazing, isn't it? Not only this, but Mendeleev even attempted naming them. Can you imagine naming something that doesn't exist at all? Since these were yet to be discovered, he named them in relation to the preceding element belonging to the same group. Preceding element? Yes, Mendeleev added a prefix to the name of the element that arrived just before the predicted one in the same group. He added the prefix eka to the preceding element, which means one in Sanskrit. So all the missing elements were named with the element preceding it in the table, but with the prefix eka. For instance, let's talk about gallium first. As we can see here, the element preceding it in the same group is aluminium. Hence, gallium was predicted to be eka aluminium. Later on, when it was discovered, gallium was found to have all the same properties similar to eka aluminium as predicted by Mendeleev. Same was the case with scandium. It was named as eka boron before discovery. All the properties of eka boron were found to be almost correct on discovery of scandium. Last example that we talk is eka silicon. Now where will this be? Yes, just below silicon. And this element, what we know today, is germanium. And similarly, there were other elements discovered later and could be placed in the table with ease. This is how Mendeleev not only designed a good periodic table, but even gave a wider scope for future scientists to discover the elements. Now on the similar lines of prediction, we've moved towards the next achievement. During Mendeleev's era, noble gases were not really known. Thus, after discovery, placing them in the table would have been a challenge, right? Not really. We know that Mendeleev had arranged the elements based on their atomic masses. So if noble gases discovered later had to be placed in between, then that would mess up the entire table. However, the table was designed such that even with the discovery of noble gases, it would not be disturbed. Yes, the noble gases like neon, argon and xenon were discovered very late. Why were they discovered late? It was because of their inert nature. Yes, because of their inert nature, they do not react easily and are hence not really noticed. Also, their extremely low concentration in nature added to their late discovery. However, as mentioned earlier, the discovery of noble gases did not really disturb the entire table. In fact, they could be arranged in an altogether different column in one corner. With all these achievements, Mendeleev's table emerged as a very powerful tool in chemistry for studying elements. However, it was not without any drawbacks. The table had its own limitations. Let us discuss the limitations of Mendeleev's periodic table in the next video.